Okay, let's start with. Okay, so I was here. Would review the programs you've written so far. Okay, would it be possible to define is shorter as a const expert? Think I was. I think I was trying to do that. Let's to go to exercises, then section 6.5.2. Yeah, okay. And 6.6.4.6.cpp. Alright, then we can go here. Okay, so I wrote this because hi and hello all the objects. Okay. So const expert, it has to be a constant expression, right? How do I make it a constant expression? Right. Okay. So let's okay. I want to define. Let's express say string s equals to, let's see if this works. Hey there. Right. And so I can go term. Okay, so I am here in the terminal. How do I go back? No, no, that is not how you go back. I think I would need a little help. Yes, where is it? Where is it? Yeah, there we go. I would definitely need some help. Okay. Okay, so control and this. Okay, that's two keys. Control and press this, then press this. Okay, so I call this, then this. No? Um, no, it don't work like that. How do you exit terminal mode? Hold and press. Hold control, then press this. Then press control N. Okay. Am I going to be fighting my terminal? Sorry, but I don't seem to understand this. Exit. Run a single command, quick and temporary. Okay. A shorter terminal. How to go back to normal mode? Now pressing space R. Okay. How to go back to normal mode from terminal mode and control backslash followed by control N. Use the mouse scroll wheel if mouse support is enabled. Simply switch windows. Escape. Okay, so if I go right and then I go terminal. See, it cannot change, modify. I go insert and then I go G++. Plus 23, then I have 6.46.cpp. Unrecognized. Yes, my bad. Okay, so const expire actually gives the previous declaration. But how do I write nvim? Not an editor command. Can't figure out to commenting in insert mode. It's supposed to press how I still don't understand. Terminal again. Okay. Okay, that was the problem, right? So I can just go it as F, right? Okay, so it gives me an error in function main start string alloc is not a constant expression. So that's an error. Oh. Okay. Okay, so because these are not constant expressions. Okay. So what I think is we cannot make a shorter const expire because strings are not constant expressions. They are built at runtime. I think so. So I want to go here. C++, yes, okay. I'll write with R start strings not const expression. That is Are they evaluated at runtime? Can be used in context in C++20 and later, but is not a fully compiled time, like string literal. Okay. Yes, in normal usage, steady string. Okay, this is wrong because performs dynamic memory allocation. Dynamic allocation is not allowed in. Okay, so third string was strictly runtime. So C++20 relaxed the rule. Dynamic allocation is allowed, but constant evaluation. During constant evaluation, as long as allocation and deallocation both happen inside the constant expression, no memory escapes the constant evaluation. Okay, but there's a catch. The catch, it's still not a compiled time string literal. The std string is not a literal type in the same as const catch. Thus, okay, it can conceptually manage. It still conceptually manages dynamic memory. It cannot be used as a non-let runtime. Okay. What is truly compile time? These are truly compile time. Even better in modern C++ is string view. No allocation, just point up the size. Fully const expert friendly. Zero runtime. Okay. So is jet string evaluated at runtime? Yes, constructed in that runtime probably allocates heap memory. So soaking in. Even if small string optimization stores in line construction will still happen. The stud string is a naturally const expert because it owns memory. Right. Okay. So I was correct. Okay. It's for debugging. A C++ programmer sometimes use a technique similar to header guards to conditionally execute debugging code. This idea is that the program will contain debugging code that is executed only while the program is being developed. When the uh, when the application is ready to ship, the debugging code is turned off. This approach uses two preprocessor facilities, assert and debug. Okay. The assert preprocessor macro. The assert is a preprocessor macro. Preprocessor macro is a preprocessor variable that acts somewhat like an inline function. Okay, the assert macro takes a single expression which it uses as a condition. Okay, evaluates expression. If the expression is false, 0, then assert writes a message and terminates the program. If the expression is true, non-zero, then the assert does nothing. Alright. The assert macro is defined in the C assert header. As we've seen, preprocessor names are managed by the preprocessor, not the compiler. As a result, we use preprocessor names directly and do not provide a using declaration for them. That is, we refer to assert, not std assert, and provide no using declaration for assert. Great. As with preprocessor variables, macro names must be unique within the program. Programs that include the CSet header may not define a variable, function, or other entity named assert. In practice, it is a good idea to avoid using the name assert for our own purposes, even if we don't include CSet. Many headers include the CSet header, which means that even if you don't directly include that file, your programs are likely to have it included anyways. The assert macro is often used to check for conditions that cannot happen. For example, a program that does some manipulation of text might know that all words it is given are always longer than a threshold. That program might contain a statement such as this. ndebug, the ndebug processor preprocessor variable. The behavior of assert depends the behavior of assert depends on the status of a preprocessor variable named ndebug. If ndebug is defined, okay, if behavior of assert depends on the status of a preprocessor variable named ndebug, if ndebug is defined, assert does nothing. By default, ndebug is not defined, so assert by default assert performs the runtime check. Okay. We can turn off debugging by providing hash define to define ndebug. Alternatively, most compilers provide a command line option that lets us define preprocessor variables as this. Okay, has the same effect as writing in the beginning of a main.c file. So, if ndebug is defined, we avoid the potential runtime overhead involved in checking various conditions. Of course, there is also no runtime check. Therefore, assert should be used only to verify things that truly should not be possible. It can be useful as an aid in getting a program debugged, but should not be used to substitute for a runtime logic check or error checking that the program should do. Okay. In addition to using assert, we can write our own conditional debugging. We can write our own conditional debugging code using ndebug. If ndebug is not defined, the code between if not defined and endif is executed. If ndebug is defined, that code is ignored. Okay, so we have let me make a new directory. I'll say 8 for debugging. Then I want to make a new file called what do I call it? I'll just call it debugging.cpp. Right. So we include cassert, we include print, and we can make a main function. Right. Okay. I want to see how can we split. Okay. Split open terminal and split best workflow. Okay. So I can go, okay. So I can go split with terminal. Okay, so this is a horizontal split. And how would I select between different include so it is vsplit Okay. Mm, okay. I have split the terminal. Now, how can I switch? How can I switch between? Like, can I switch between the terminal and my CPP file? Perfect. One split. Understand terminal. Leave terminal. Yeah. Normal mode. Move left. If terminal is on the right, go back. Okay. क्या था इसका? Move right. Control WL. Control WL. Oh, okay. And then Control W. Control WH. Okay, great. Okay, great. LS right. Okay. Hmm. Um. Terminal split. Undefined behavior. Okay, so void print if not defined and debug. Func is a local static defined by the compiler that holds the function's name. Okay. Here we use a variable named func to print the name of the function we are debugging. The compiler defines func in every line in every function. It is a local static array of const char that holds the name of the function. Okay. In addition to the func, which the C++ compiler defines, the preprocessor defines 4 other names that can be useful. Okay. So string literal containing the name of the file, integer literal containing the current line number, string literal containing the time of the file was compiled, date. Okay. We might. Okay. Okay, I still cannot seem to figure out how. Nope, I don't know what. Okay, I'm in insert mode. If I go another split, okay, there it splits it, but I don't want the split. Uh, um, we split creates it vertically on the right immediately. Open a file. Side right split. Terminal. Resize it. Control. How do I? How do I unsplit the window? Can I do that? Oh, okay. So control W L. Control W L. Where am I? Oh, okay. Okay. We split terminal. Okay. Now, how do I? Now, how do I? Okay, doesn't really matter. Alright, so we can define a function print, right? This is the function print where array size is okay. So we are taking an array constant a and then size t size. Then we can check if not defined and debug. What we can do is we can I'll stream. Okay, let's see here. Let's say we can go funk, right? This should be enough. Then I can, huh? I can do an and if. And then I can move here and C++ 23. Okay, I didn't call the function, so that is my bad. Sorry, I didn't mean to do that. Can I? split, no, quit, yeah, okay, v split, right, okay, then I want e debugging.cpp, yes, thank you. Then I want to insert here, I want to call this function print. Let's make an integer pointer p equals to some value 0. I would just go 0. Then I can just pass p and I can pass 3. Right, okay, no, so I want to move here to the right, and I want to call this print. Okay, so this is the name, print. Okay, then we have function matching. If in many, if not most cases, it is easy to figure out which overloaded function matches a given call. However, it is not simple when the overloaded function has the same number of parameters, and when one or more of the parameters have types that are related by conversions. Okay, yeah, double calls void double. Okay, so there we go. Then we go control shift H. Now I'm here, and I can make some function. Let's say int sum, int a, int b. We can return a plus b, right? Then I can go assert 3 equals. I just simply say that this should be true, right? Okay. This will fail. This will fail if, okay, this will fail. This will fail if false, right? We can only use the the checks will only happen. The checks will only happen when, alright, the checks will only happen. The checks will only happen when n debug is not defined. Alright. Okay, so we saved the file. Then I can okay, this is great. But if I go here, let's say if I say 4, right? Then then I go like this. Yeah, so assertion failed. It will say assertion failed. I think I can put an assert. Hmm. Okay, so the assert header, assert this macro can um, help programmers find bugs in the programs or handle exceptional cases like crash. That will produce limited debugging output. If expression is false, that is compare equal to 0, assert prints an error message to its standard error and terminates the program by calling a point. The error message includes the name of the file, the function containing, okay, line number. Library function. I think we can. There used to be. No, no. Hmm. I think there used to be a thing where we can supposedly end it with our error message and it would show up. Some is wrong. Think that's how. Hmm. Yeah. Error. Some is wrong. Some is wrong. Failed. Failed. Okay. And if I didn't do that, right? Right. Say if the sum. If my sum was correct, right, then it would not. Yeah. Okay. Great. Yeah. Okay, so I wanna get rid of this. Then let's move ahead. Okay, function matching. Okay. Revise a program you wrote in exercise 6.3.2 that used recursion to print the contents of a vector to conditionally print information about its execution. For example, you might print the size of the vector on each call and run the program with debugging turned on and again with it turned off. Okay. Assert. Right, so we can do this. Where am I? I'm here. Right. Okay. I want to go to exercises and then I want to go to section 6.3.2 ls, which was it. Page 228. Can I cat 6.6.332.cpp? Nope, this is not it. What is all? Oh, 6:30. Okay. cat. I'm going to say cat. Yeah, okay, so this is subrange. Okay, same size as written normal equality test. Okay. Let's give me 6.33.cpp. Print static index vi size print vi. Okay, what was the function? Write the program to route index size that use recursion to print the content. Okay, I think I am using recursion. Yes, I am using recursion. So we will pwd. Okay, this is okay, but now it would be difficult for me because I don't know how can I copy it like this. Paste, copy, then I can paste. Yeah, okay. At least this works. Okay. Oh. Right. Oh, sorry. Why? Right. So now I have copied a line, and then I can paste it like that and undo. No, no undo. Okay. Alright, so I wanna CD to I am currently in one more 6. It's for debugging. Yes, 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 yes. Okay, right, correct. But I wanted to go to exercises. Yeah, and this is exercise 6.5.3. I'm going to make a directory. Aiming section 6.5.3. Okay, and then I want to cd to the section 5.3 and no. Okay, I want to copy 2 lines. I think I have copied 2 lines now. We'll see if this will work. And I can paste. Yes, I have copied 2 lines. Great. Now I can go to insert mode, and I think it was exercise as far as I remember. No. Okay, I want to move. No, sorry, not move. Copy. Okay, end of the line. Yes. Copy right from there. I think it was. If I okay, I'm mostly struggling with Vim right now. So let's go to the top. Which one? 6.33. All right. I cannot jump. we jump to the end like that. It is 6.33.cpp, and I want to copy it to here, right? And maybe we put everything in nice dots. Yeah, okay, let's see. And I want to rename it to 6.47 6.33.cpp to 6.47.cpp, and okay. Right. So, no. Yeah. Okay. And I want to quit this. We split. Where am I? Okay, I'm here. I want to open file 6.47.cpp. Okay, I'm on debugging still. Alright, 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 alright. Let's no, I'm in the correct that, right? Okay. Okay, but I didn't want it to be there. Why is it showing it? Okay. Um. Okay. Great. Okay. Exercises. Section 5.3. Yeah. Then we go split terminal. Hold up, for example, you might print the size of the vector on each column, compile it with programming. Okay. Revise the program we wrote in exercise that used recursion to print the contents of vector to conditionally print information about its execution. For example, you might print the size of the vector on each column. It would still, the size of the vector would remain same because we are taking reference to the vector and it's not going to change. So we have if not define and debug. I can print vi.size. And if using this uh, using this to do what? um, if not define debug, so we have using this to optionally print information, right? Great. Then this is up. Okay. I have written data to this. So let's compile the program. Yeah, I should have written this. Control W and L. It's like size of vector. Alright, so these are the vector files. Okay, great. Alright, so that is done. Okay. Explain what this loop does and whether it is a good use of assert. String is, we take in string until it is not equal to some already string that we have used, then we assert if the stream is valid. I don't think this is a good use of assert because we are validating the stream itself. Validating the stream itself. Just not useful. I think so. Let me try and do that. Okay. Terminal here. Alright. Okay, so I'm getting used to this. Slowly but surely. Why won't it move? Oh. Okay. So let's what do I have to do? Okay, escape that terminal. Oh, shift. Sorry. Control. Yeah. then I want to open file 6.48 6.48.cpp. Let's go hash include stream, and I think that is all I would need. And then we write a main function wherein we have say, okay, I need the string 2. I should include, what do I need to include? I need to include string thought equals to hi. Then we go while theme, then we have another string stud string s nothing. Okay. String s, no, what is and s is not equal to sort empty body. And okay, so I would how do we jump? I think it was G, right? Double G's. And I would like to include cert, then we jump, then we come down over here, and then we are asserting steady cn. Okay, let's see how will this 6.48.cpp dot out, or does it? Okay, so it is asking for my hello. I go hi. Okay, assert if the stream is true or not. Stud. Okay, what does the stream? What does assert? Okay, what? Dash GTP and 6.48.cpp. Do I have GTP? GTP, so GTP. Sure, man. Okay. GTP dot out, right? Okay, I want to put a breakpoint and use 6.48.cpp at 11, line 11, right? I believe that is line 11, right? Because 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. And now I can. Sorry, what did just happened? Okay. If I can run. Ah, oh, okay. Hi. Said, can I print CDCN? Syntax error. Print CDCN. Incomplete type. Okay. What does assert? One, two. Undefined command assert. Okay, undefined command assert. Hmm. Let us see what can we do. What can we do? Um, invalid type command assert. Okay, incomplete type. Says incomplete type. Okay. Yeah. Clear. Okay. This is really annoying. I think I will just quit it. Exit. Yeah. Okay. Okay. Let's ask. What would happen, right? Okay. So what does the strings represent? Right. Okay. This here, yeah. Standard IO stream. Okay. Okay. Diagnostics. All right. File descriptors. Yes. Yes. But buffered. Okay. Um. CN. Okay. Yeah. Okay. Say got pulled. Let's try to let's make it a little bigger. Okay. So we go IO stream, right? Okay. Then I want to see. So go stdcn. Okay, and I want a bunch of string too. Right. Then I declare. Right. And take S. Compilation failed. Okay. Okay, so what is basically okay if I write if cdcn, what would happen here? Yeah, okay. So bool basic IO something, right? And I have a string something, and I can maybe run it. Can I run it somehow? Where can I run this? Where can I run this? Okay, yeah, okay. So I'm going to add it into um n1. Huh. Let's go to term. Right. So I want to let's okay. That's okay, yeah. CD tune curiosity findings. Okay. Then I want to make a new directory. Um, something about streams. Something about streams, right? Okay. Then I will make a you can touch a new file in main.cp. Right. Okay. Then we can do a split, and I can move here. I can insert. I can open the main.cpp file here. Oh, insert. Give me a terminal here. Escape. I want to open file main.cp. Um, this is really confusing. Quit. Okay. Quit. Right. Okay. CD to curiosity finding CD. Oh. CD to. Okay, there is nothing right here. Okay. So I can create a new file main.cpp. We'll go IO stream. Then we can go let's try something happens. Right, okay. Now I'll do a resplit terminal. Main.cp. Okay, then we can go. Something happens. Okay, so this is a right. This is a valid object. So they're saying that this is a valid object. I'm going to go, let's say 50, some like where are the if statement, where are the streams, right? Okay, streams, where can you, the for statement, can you give me some streams for control? What about comments? Completing program, standard input output, yeah, okay, that's right, this is it. The library defines the object to handle input. We use an object of the type iStream named cin, pronounced cin. This object is also referred to as standard input. For output, you use okay. Ordinarily, we typically use CR referred to as standard error for warning in error messages and CLOG for general information about the execution of the program. Ordinarily, the system associates each of these objects with the window in which the program is executed. So when we read from cin, data are read from the window in which the program is executing. When we write to cout CLOG, the output is written to the same window. Okay, so right here to a stream. So the first statement in the body for main executes an expression in C++, an expression yields result and is composed of one more operands. Okay, takes two operands, that is a string literal. Using named reading, okay, reading from a string, having asked. The input operator behaves now. The output operator, it takes an iStream. Okay, this is an object, left hand operand, and an object as its right hand operand. It reads data from the given iStream and stores what was read in the given object. Like the output operator, the input operator returns its left hand operand as its result, hence the expression. Because the operator returns its left hand operand, you can combine a sequence of okay. Right, so I think this is a good use of set because we are validating the stream itself. Yes. Right, because this is an object, this is a valid object. We can check that. Let me ask. Set FCN, right? C has a conversion to bool. This checks whether the screen is in a good state, no fail bit, or set means about the program is currently in a fail state. So why this is usually wrong? Set is for programmer errors. Okay, alright. Stream itself, that's not useful. It should be used for internal program errors like the pointer or the right. Okay. Determining the candidate and viable functions. Okay. The first step of function matching. Okay, this is function matching. Then argument type conversions. I think I've done a lot. Okay, so we'll close it here.